Algebra 2 class, this is the end of our week. So this is Thursday, April 23rd, and our fourth week. This will be the end of our fourth week of home learning. And here we go, 14.2 parabolas. That was one of the cross sections we saw yesterday, and cross section of a cone. And this is on page 622. Now, parabolas are familiar to us in daily life because the cross-section of a satellite dish is a parabola. And in fact, a parabola is really a three-dimensional paraboloid, the satellite dish, that focuses all the rays of the satellite to one point, the receiver. Now, if you ever looked at a dish satellite or any other satellite, there's always a shaft coming up from the middle, and it has an end to it, and that's where it receives. So all the satellites bounce in, and a paraboloid or parabola has the distinct advantage that it focuses all those beams that bounce in on all the points of the dish. So that's why it's so useful. It focuses things, and it's used in headlights and many other things. So now our definition, though, for math is a parabola is a set of points in a plane equally distant from a given line, the directrix, and a fixed point not on that line, the focus. And as we'll see, the vertex of the parabola is always midway between the focus and the directrix line. So example 1, write the equation. This is where we'll derive the equation for the parabola with focus 0p and directrix y equals negative p. Now notice on our parabola, we have a vertex there with the v on it at the bottom of the parabola, and we have a focus point f 0p, which is up p from 0, 0, and below it, minus p below the origin, is this directrix line, y equals negative p. So now the equation comes from the distance between the focus point, 0p on the y-axis, to any random point being equidistant to the straight down directrix from pxy to d down on the directrix line of x comma negative p. So the way we find the parabola equation is we set fp, or the distance from the focus point to the point on the parabola, equal to the point on the parabola straight down to the point on the directrix line. So that's easy enough to do. We just take the difference in the x's and the y's for both parts. So for the first distance, fp, we say x minus 0 squared plus y minus p squared is equal to, for the PD part, the straight down part, x minus x squared, which is 0, plus y minus a negative p, or y plus p squared. Now, because they're both square roots, those are distances, we can square both sides and come out from under the square roots with x squared plus parentheses y minus p squared equals y plus p squared. And now we're going to expand those parentheses with the FOIL. So x squared plus y times y, and then minus py and minus py for the FOIL, outer and inner, and plus p squared for the last. And then on the right side, we have y squared on the FOIL, plus yp plus yp plus 2py, outer and inner, plus p squared. Now notice that the y squareds and the p squareds cancel on both sides of the line, because the parentheses terms have both y and p in them. So what we're left with is x squared minus 2py on the left is equal to 2py on the right. We add the 2py over and we get x squared equals 4py. Now in order to understand how we use these things, we need to see y equals 1 over 4p x squared, and that 1 over 4p is called the a, like we usually have on any parabola, which determines how fast or how slow it rises. Okay? Now, on example 2, we want to write the equation of the parabola with vertex negative 2, 3, or hk, and p equals negative 2. Now negative p means the parabola opens downward, because we have upward and downward, and the vertex shown there at 2, -3 is again the midpoint between the focus and the directrix line. So notice when the parabola is opening downward, because p is negative, the directrix line is p above the vertex, and that would be p above -3, or let me see, -3, or that would be 5, okay? So now we have y equals a, x minus a squared plus k, and so we have, using the vertex 2, -3, we have, it's minus 2, 3 is what's really going on there. So minus -2 squared plus 3 minus 2, 3, I miswrote it on the picture, it's -2, 3. And that's why y is 5, because it's -2, 3, and the focus point below it is -2, 1. So that was a misprint on my part. Okay, so using the vertex, we have a, x minus a -2 squared plus 3, and a, as we saw before, up in the original derivation, is 1 over 4p. For us, p is -2 because it's going down 2 from the vertex to the focus. So 1 over 4p is 1 over 4 times -2, or -1/8. And there we have our final equation, y is equal to -1/8 times x plus 2 squared plus 3. Now for example 3, we want to write the equation of the parabola with focus 3, 2, and directrix x equals 5. So now this is showing us that we can open left or right, which we usually hadn't done before with parabolas. We usually just had them open up or down. So with a -p here, we're going to open to the left. As we can see, our focus is at 3, 2, but putting the x equals 5 behind it forces the vertex to be halfway in between 3, 2 and 5, 2, so the vertex is at 4, 2, halfway in between the directrix and the focus, and because it's opening back, the x equals 5 directrix is behind the focus, it opens to the left, which is a -p. So p is -1 because of the distance between the vertex to the focus is -1, the left direction. So a is equal to 1 over 4 times -1, or -1/4. Now the vertex is 4, 2, so plugging in we have x minus 4 equals -1/4 y minus 2 squared, and now multiplying both sides by -4, that gives us -4 parentheses x minus 4 is equal to y minus 2 squared. Then we can square root both sides, and when we do that, we get the y minus 2 squared to come out as y minus 2 under the square root, changing sides, and I would have plus or minus the square root of 4 minus 4 parentheses x minus 4 plus 2. So y is equal to plus or minus square root of -4x minus 4, and then outside the square root plus 2. So here we have for this one now, that's for this one up here for example 3. Now you can graph that on the calculator, but I don't think we really need to do much more than just have the focus, the vertex, the directrix, and then just freehand sketch the parabola. Now, what I'm going to show you next is the 4 ways that parabolas can open. The most obvious way is opening up. So I'm going to have a vertex at 2, 4, and I'm going to have it open up. So the distance from the vertex to the focus is the p, which is 2. I have my focus at 2, 6, and I go from my v, 2, 4, to down 2 to the directrix line, y equals 2. And so then we have an a of 1 over 4p, or 1 over 4 times 2 is 1/8. So my equation is for opening up from a vertex of 2, 4, 1/8 x minus 2 squared plus 4. Now for opening down, keeping the same vertex, we have our focus, or we have our vertex at 2, 4, but now it's down 2 to the focus, so that makes the p negative 2. That makes the a negative 1 over 4p, which is negative 1/8. And we can see the focus at 2, 2, but the directrix line up above the vertex and the focus, which forces the parabola down. So that equation would be negative 1/8 x minus 2 squared plus 4, and you can tell it opens by the negative 1/8. The negative makes it go down. Now here, to look at opening right, which would be comparable to opening up, and left, which would be comparable to opening down, we're going to make the vertex at 4, 2, and putting it at 4, 2 for a positive p of 2, the focus would be at 6, 2 going 2 to the right, but the directrix would be 2 behind, giving us an x vertical directrix line of 2. So x equals 2. And that equation would be using the vertex 1/8 y minus 2 squared, because y is 2 in the vertex, plus 4. Now to get it to open left, you can imagine that we have to have a negative p of 2. And so from the vertex at 4, 2, we go left 2 to the focus of 2, 2, with the directrix line behind it at x equals 6. And this equation turns out to negative 1/8 y minus 2 squared plus 4. So that's how I get my 4 cases. Now for the homework, starting on page 624, we start with negative 1/2 y squared equals x, and we multiply both sides by negative 2 to clear out the negative 1/2. This gives me y squared equals negative 2x. And remember, when it's y squared, x squared goes up, but y squared goes left or right, and the minus 2 in front of the negative 2x makes it open to the left. And it's good to just sketch it to keep your mind straight with y squared with a negative opens left. Okay, for 14 we have 16y plus x plus 3 squared equals 12. And now dividing everything by negative 16, we would have, negative 1/16, because here's what we would do. We would have x plus 3 squared. We would subtract the minus 16y over and subtract the 12 over to the left. So we would have x plus 3 squared minus 12 equals negative 16y, and then we would divide everything by negative 16 to get y equals. So that's what gives us y equals negative 1/16 x plus 3 parentheses squared plus 3 over 4, which is negative 12 over negative 16, simplifying. And again, with a y equal and an x squared, that would open down, because x squared is the regular parabola that opens down. Okay? Now on 6, we're told that the vertex is 4 minus 1, and the focus is 2 minus 1. That's opening to the left again with a p of minus 2, and the x is 6, and that's all we need. And now from here, for a while, we're going to look at how the vertex goes to the focus to determine the coordinates rather than graphing them. So if we're given the equation y equals 1/4 x plus 6 squared, that's going to be x squared plus going up minus 4. So p is 1/4, the number in front, or p is 1 over 4 times the number in front of the parentheses, 1 over 4a, a is the 1/4. So 1 over 4 times 1/4 is 1, okay? So what that gives us is a vertex of negative 6, negative 4, you see, but the p is 1, so the focus is 1 down on the y, so the focus is negative 6, negative 3, but the directrix opens up backwards from that, y equals negative 5 below, okay? So the focus is the highest point, and then the vertex is below it, and then the y equals negative 5 directrix is below that, okay? So for 10, we have the equation y plus 2 equals negative 1/20th x plus 4 squared. So subtracting over the 2, we have y equals negative 1/20th x plus 4 squared minus 2. Now that's the x squared with a minus a, minus 1/20th, so that's opening down again. So p is equal to 1 over 4 times a, 1 over 4 times negative 1/20th, which is 1 over negative 1/5, which is the reciprocal of 5, negative 5. So p is negative 5. Now from the equation, we have the center of the parabola is, vertex is negative 4 and negative 2 for y. The p is negative 5, so we go down 5 for the focus, and the directrix line is negative 2 plus 5, or y equals 3 up above it again. Okay? For 12, we start with x minus 3 equals 2y squared, add the 3 over, so we have x equals 2y squared plus 3. Now this is going left or right, and because it's positive, got a positive a of 2, it's going to open right. So p is equal to 1 over 4 times 2, or 1/8. And so the vertex being at 3 for x, comma 0, then the p being 1/8 is going to go up to the focus on the x. 3 is 24/8, and up 1/8 is 25 over 8. And then, so it's going to the right, and the directrix line is 1/8 behind the vertex on the x-axis, or a vertical line of 24/8 minus 1/8, or 23/8. That's how I get behind it, and it opens to the right. Now on 14, we have a focus of 0,4 and a vertex of 0, 0, which makes our p4, and we have a equals 1 over 4p, which is 1 over 4 times 4, or 1 over 16. And so we have y equals, this is a regular upward going parabola, y equals 1/16 x squared. And again, the directrix is 4 below the 0, 0 vertex, forcing it to go up with a y equals negative 4 for the directrix. On 16, we have a vertex at the origin again, but with x equals negative 3, then it's going to be opening to the right, because then the p will bring us up to the vertex at 0, 0, which we knew to be the case, and it'll be 3 from the vertex to the focus at 3, 0. So that's just a quick sketch, and that's all we need to do there. Okay? So 18, y is 2 times x minus 1 parentheses squared. And this is going to be an x squared opening upward because 2 is positive. So p is 1 over 4a, or 1 over 4 times 2, 1/8. And again, we're going to see that the vertex is at 1, 0. And we're going to go up 1/8 y. So the focus is 1, 1/8. And the vertex is y equals minus 1/8, below the vertex. Okay? And for 20, we have y equals negative 1/12 x plus 5 squared plus 4, and that's going to be an x squared with a negative, so that opens down. The p, the distance between the vertex and the focus, is 1 over 4 times negative 1/12, which is 1 over negative 1/3, or negative 3. So from the equation, we have a vertex at negative 5, 4, but the p is taking us down 3 to negative 5, 1, and that puts the directrix line up at 4 plus 3, y equals 7, up above the vertex, forcing it down. Now 22 is the only one we complete the square on, like we did for circles yesterday. So remembering x squared plus 6x plus the 6 over 2 squared gives us the x plus 6 over 2, 3 squared below, and then minus 4y equals minus 1, which was there originally, plus the 6 over 2 squared, 9, which is from completing the square on the left. So we have x plus 3 squared minus 4y equals 8. And we're going to add the 4y over and subtract the 8 to get them on the other side. So we have x plus 3 squared minus 8 equals 4y. We divide everything by 4 to get y equals. So that gives us y equals 1/4 x plus 3 squared minus 2. So that's going to open up. And our vertex is at -3, -2. Our p is 1 over 4 times 1/4, or 1 over 1. So the vertex goes up 1 from -3, -2 to -3, -1. But the directrix line is below them both at y equals -3, -1 from -2. Now 24, x equals 1/3, y minus 1 squared plus 4, that's a y squared with a positive 1/3, so that opens right. P is 1 over 4 times 1/3, or 1 over 4/3, which is 3/4. And now from our equation, our vertex is 4, 1, and we have a p of 3/4, but on the x, so the focus is 4 plus 3/4, or 4 3/4, comma 1, and the directrix line is back, because it's opening right, minus 3/4 from 4, or x, the vertical line of 3 1/4. Now the last one is y equals -3x squared plus 2, and that's an x squared with a -3, so that opens down. P is -1 over 4 times -3, or -1/12. So our vertex is at 0, 4, and we just want to go down a smidgen. This is -1/12, so 4 minus 1/12 is 0, 3 11/12. And up from that, so it will go down, the directrix line is 4 plus 1/12, or just 4 1/12, the horizontal line. So that finishes this section. This was a little bit longer, but let's just keep doing what we're doing and keep up the great work. God bless you all. This is Thursday, the end of the week.